So last time we stopped here. So the thing that before I forget to mention is I told you, I guess 2 lectures ago, I gave you a bonus question. I know that there is no folder on Avenue yet to submit this, and you guys don't even have this question in the slides, right? So I'm going to post this today, and don't send this to CompEng to SH4 for those who have already done. Please, when I create the folder today, submit to this folder, right? Don't send any files to CompEng to SH4. We did this just in the first quiz because we had problems with Avenue, but now everything should be on Avenue, right? Okay. The other thing that I'd like to mention is my plan that I hope it works is for quizzes, remaining ones, is we are going to build on top of each other. So we had one class that we call student. I told you this yesterday. Later we should use this class. So even if you weren't able to finish it completely during the lecture, maybe you can continue it at home, right? Because later in a second quiz, if you're going to use it, maybe it's better to have it ready rather than wasting the time of another quiz in this question, right? So do your best during the quiz and then try to continue doing it at home if you feel you need more time, right? And at the end, quizzes are for practice, right? So it's good to also think about them when you have time and then you relax in your couch at home, right? Rather than being stressed in the lecture. Good. Is there any question? Good. Also, the first lab in Java has already been posted, I guess, yesterday or on Tuesday, so you guys should start looking into this. Method overloading. What do we mean by this? This is one of the most beautiful things in OOB. This is also existing in other languages like C++, and something that may seem very confusing if you don't know the concept itself. Assume you open a big project that is OOB based, and then you find multiple functions. Sometimes these are like 5, 10 functions with exactly the same name. But we know from C that this is not allowed, right? Because if you define multiple functions with the same name in C, and they take different like number of parameters, for example, which one you are going to call when you give the name or call the name of the function in the main or in another function? You don't know, right? So the compiler will kind of get confused and give you an error. Good? In object-oriented programming, there is a very, as I said, beautiful concept that we call method overloading. You don't need to define a different name for the same function that it's doing the same thing, but takes, for example, different number of inputs. Why this is even needed, right? Sometimes you want to write your function in a certain way under a certain scenario. But also you want the exact same function to do the same operation, right? The same job, but under a different scenario. One example would be, you kind of assume a knowledge of like 2 variables. You know that you take these 2 values and then do some operations on them. But in case you have more knowledge about other variables, like if the user was generous enough to give you more information, then maybe you do your function in a more efficient way. That means now you can have 2 different implementations of these functions. But instead of just defining completely 2 separate functions or methods in Java, this overloading concept allows you to define the same method twice with exactly the same name, but it takes different number of input parameters to accommodate for both cases, or in general for any other case, right? So what is method overloading? Basically, you have the same name for multiple methods. Effectively, they are the same method, but each one of them, each implementation, each body of the method takes different number of input parameters. You can have, like, let's say, I don't know, get name, maybe not get name, like add function or add method that takes 2 inputs and then add them, or 3 inputs and add them, 4 inputs and add them, right? And at the end, everything is the same, adding whatever inputs you get. Good? You can also think of this as a different way of getting around that you have to know your number of input parameters beforehand. Because every method has to know what are the input parameters. But what if I don't know them? What if I have, as I said, different scenarios? Then you do this method overloading thing to accommodate for as many as number of input parameters that you can imagine your user will need, 2, 3, 4, 5. Then for each one of them, you have a different case. Good? So this is why called like overloading, because you overload the name of the function. You use it like in different cases. Good? Another thing that is important is it doesn't really matter what is the return value. What is important is what is the number of input parameters. So if you have two functions with the same name, overloading works if you have the same function but with different number of input parameters regardless of what is the return value. Good? Let's see one example. So something that we have here for the constructor, remember what is constructor from yesterday? The special method that gets created when you instantiate a class or create an object from that class. Here we have two constructors, right? One of them takes two inputs, the other one takes no inputs. And both have the exact same name, which is from yesterday, you know, constructor has to have the name of the class itself, right? It's not necessarily to be two. You can have as many as you would like, but two is just an example. This one takes two inputs, which is our left bound and R bound, which means if the user provides these inputs when instantiating the object, then you are going to use them. That means this constructor is going to be called. But if the user just defines an object without initializing the L bound and R bound, without giving values, then also this is valid, but this constructor is going to be used. So the language or the compiler knows by default which of these methods you are referring to based on the input, the number of input parameters. So, let's see one example. So here in another class, in a main function, we define two different objects of the same class, which is new interval. One of them is initializing, giving two inputs. The other one is giving nothing. If you execute this line, what the language will know is here, you are instantiating an int1, but then calling this constructor. So it's going to take this one, compare which one is smaller, which one is larger, and then assign it to the left bound and R bound. What happens here? You provided nothing, which means you don't need to initialize your values, and then this constructor is going to be called, and then values are going to be initialized to 0 for you. Good? Yeah. Yeah. This is a question that makes me sad. But that's good, because we know this from C, right? This is called conditional operator. What does it do? It's not very common, honestly, in programming, so people rarely use it. But what it does, you can think of this as an if condition, right? So here what you say is, if A is less than B, then L bound is equal to A. Otherwise, L bound is equal to B. But just it's a more easy and fast way to write it, right? So this also exists in C, so you guys need to make sure that you know this, right? A condition and two different values. If the condition is true, it gives you this. If the condition is false, it gives you this. Good? Thank you. Okay. Good. So now to check which one has been called, we are printing the L bound for both objects. For the first one, using our get L bound method. For the first one, we get 1 because we initialize L bound to 1. But you can imagine that for the second one, we get 0, right? Good. Another thing that we want to discuss is what is this? We have used this yesterday, and today also we're going to use it. Methods of the same class have access to the variables of that class, right? So we had L bound and R bound. Good. But then get and set are using L bound. And they use them either by putting the word this, so you can say return this to L bound, or just directly, right? What is the difference? First of all, what does this refer to? This is referring to the class that you are in right now, right? This is equivalent to say new interval dot something. And use it only within the class, because You are referring to yourself, right? So a very important thing that we need to understand, or differentiation between different types of objects that this is related to, is you can use this for the local variables. What does it mean to be a local variable or an instance of a variable? It's basically the global variable that you define outside any other method. So to give you one example, and also this is the same concept that we have from C. Remember that we have global variables and local variables, right? Global variables are across the program. Local variables are within just a function. You can have a variable, two variables with exactly the same name. One of them is global and the other one is local. Right? How do you think this can be handled? If I define two variables as int x, one is global and the other one is local. Which one should be used when I refer to it? Can someone imagine what would happen? Maybe this is for a bonus mark. And this is for C, it has nothing to do with Java. Okay. The question again is, I defined two variables with the exact same name. One is global, the other one is local. Global means outside any function. Local means within a specific function, within the main, for example. Which one should I use? Or in other words, if I said later y equal x plus z, this x is the global one or the local one? Both can have a different value, right? Both are different places in memory. Would you say this again? No, you don't have to, because it's just a global one. It's also visible. Remember that global variables are visible across the project, including even the main and any other method, right? Yeah. So, not completely, right? Yes, in a certain scenario. But, and again, my question may be, don't take my question as which one should I use. What I'm saying is, if you use x throughout your program, which one is going to be, which value is going to be substituted by the compiler? Is it the global value or the local value? Right? Yeah. Yeah, so what you're saying, and please correct me if I'm wrong because I'm just barely hearing. So what you're saying is outside the block of the local variable, you're going to use the global one, right? But inside the block of the local variable, you're going to use the local one. Exactly, good, thank you. Please give me your name afterwards. So what your friend is saying is, this depends on where you are using x in the program. If you are using it in the local one, so basically the local one is the one that has more power. So if it exists, which is inside the method that you defined it, then the local variable is going to be used. If it doesn't exist, which is outside the method that you defined it, you're going to use the global one. Good? The same thing for this here. If I defined, you have the ability to define two variables with the exact same name in the same class, right? One of them inside a method, which is a local one. The other one is the normal ones that we just used, right? Which is the global ones. But now, what if I want to use both? What can I do? Here comes the benefit of this, right? If you refer only to the variable name without using this inside the local, assume the following, right? We define again two variables, int x. One is just the normal global one. The other one is inside a function, good? Or a method for this class. And inside this method, you have the capability of using the global or the local one, right? It's not like C. You're forced to use the local inside the block that you find it. How can I do this? You can do this using this, right? This dot. So if you say this dot x, because this refers to the class, that means you are asking the language or the compiler to use the global version for you, right? If you are just referring to the variable name, x without this, then now it goes back to the C situation. If it's inside the method defined x, then it's the local variable. Outside it would be the global one. Is that clear? Yeah? Good. So this is exactly what I just said right now. And here is one example, right? So we define int x. Oh, this is exactly the same example that I just gave. Here, this dot x is this one, right? But just x is the local one here, right? So it's like saying assigning this instance, we call this instance field, right? Which is kind of a global variable for the class. Assign to it the value of the local variable inside the set method, right? Is there any question? Okay. So in this lecture, we kind of study an important concept that we covered in C, but it's even more important with object-oriented programming in Java, which is defining a variable or a method as static, right? But before we go there, I want someone to remind me what is static in C. What happens if I define a variable as static in C? Yeah. Yeah, so it defines this variable to exist in the memory during the duration of the full duration of the program, right? One important differentiation also is this static variable can be either local or global. Being existing in the memory doesn't mean that anyone can access it. You can still have a static local variable that is not accessible outside its own block, right? But it will still be there in memory. And we had one example on this for the C language. Good? So the same concept exists here for Java, but it's even more extended. And the reason is we define everything as classes and objects, right? And now you can have different objects of the same class, which means you define your own data type. And then, as we have seen in the past 3 lectures, you can have different variables that are instances or objects of this class, right? For the new interval one, you can have int1, int2, int3, any number of different objects. Each one of them has its own, and we said this very clearly. When you define a new object using the new word, what happens is you create a place in the memory for this object that is different than all other objects, right? With just one caveat, which is the static thing. The static thing here, because it exists in the memory during the duration of the class itself, it's disassociated with the objects. So it has nothing to do with the objects, which means if you define a variable as static, it basically has only one value across all the objects of the class. And this comes from what we know from C is static exists during the full duration of what instantiated it, in this case it's class, and whatever you define an object or not, this variable will exist there, right? I don't know if this is clear, right? But let's visit the concept again. Assume the following example. I defined a class, our new interval class, right? But during my main, didn't instantiate any object of this class. Good? Is there any place allocated in the memory? What do you think? So I defined a class that I never used it. I didn't define any new object of that. Is there any place, is there anything allocated in memory? No, right? Because we said allocating a place in the memory or a storage in the memory using the word new when you define new objects of a certain type. In this case, it's of the class, right? So if you defined a class, like our student class yesterday in the quiz, but we didn't use it, then you just define the type that you didn't use yet. So nothing is placed in the memory. Remember, integer as a type doesn't reserve anything in memory. You only reserve something in memory when you say int x, and then you reserve the 32 bytes in memory. Good? The same thing for classes. Again, with only one exception, which is the static variables. If a class has a static variable, this static variable, once you define the class, is going to be allocated in the memory, whether you instantiated objects or not of that class, because it has to exist during the presence of this class, right? That's why static objects are independent of the objects. Sorry, static variables are independent of the objects, right? Good. If you guys get the concept, then examples would be easy to get. If you don't get the concept, if we had 100 examples, it doesn't really matter. So if you have questions, let me know. Good? So the way we define a static variable or static, what we call static field or static method, is by just using the word static, similar to C. And let's see how things work, right? For normal variables that we have seen so far, any object that you define of this class has its own set of the variables, right? So again, the example we had int1, int2, int3, int4 of new interval. Each of these objects has its own L bound and R bound that are different, and I have drawn this picture for you that if you change the L bound or R bound of one object, int1, it does not reflect in int2 because these are completely two different places in memory, right? For the static case, it's different. The static is not stored within the memory of the object. It's stored in a different memory, which is associated with the class itself, right? A static field exists in the memory even if you don't define an object because it's associated with the class itself. So once you define a class, you get this static thing. And you can think of the static thing as a global variable across all objects of this class, right? Because static variables are associated with the class itself, not the object, you can refer to them, for the first time we do this, you can refer to them using the original class name, not the object name. Again, our class is new interval, our object name is int1 or int2, int3. What we have used before is int1.l bound, int1.r bound, right? So we use the object name dot, which is the member operator, to access a certain member of this object. For static things, it's different. You have to use the class name, right? Which is new interval dot, it's not you have to. You can use the class name, new interval dot the static variable name, right? Because it's allocated with the class. What if I use the object name? What if I say int1 dot x, where x is a static variable? This still allowed, but again is going to refer to the same static one location in memory, right? So you can access static variable using either the class name or the object name. Good? You can say class name dot static file name or object name dot static file field name. Any method of the same class may just use static field name. So this is saying that you don't need to use this for the static thing. Again, because there is one storage, one variable of this type, static, and everyone has access to it. So you can just use its name without this dot something. Right? One problem we have here, which is again the same concept, and this is the benefit of getting the concept rather than the syntax, right? We know this concept from C, which is static, as I said at the beginning, has nothing to do with whether the variable is local or global, or whether it's private or public, using Java terminology, right? So you can still have a static variable that is private. What does it mean? It means that no other class is able to access. Private has the meaning that we discussed before, which is if you define a private variable, no other class is able to access this variable, right? Static has the meaning of this variable will exist in the memory during the duration of the class. Both are orthogonal to each other, right? So you can have a variable that is private and static on the same time. Okay? So let's take one example, right? So we want to write a class that basically manipulates or defines the point or the coordinates of a plane during its travel, right? Which is x and y, right? And then, so each point that we recorded during the journey of, or the trip of the flight is going to be recorded as x and y. And then, this is why we define two variables, x and y. And this should be in instance fields. Instance fields means like normal variables that we just defined. Good? But then, the new thing here is we want to keep track of how many points are recorded during the flight, right? What does it mean? You define your point class. You can have multiple objects of this class. Each one of them is calculating a point. So you calculate a point, for example, every 10 minutes, every 5 minutes, right? The coordinates of the plane during the flight. Good? But then also you want to keep track whether your recording system is working or not. Like maybe did you lose track of this plane or not? So you want to keep how many times you counted or you calculated this point, right? So now we need a counter. Each time we calculate x and y for the plane coordinates, then increase this counter by 1. Good? Maybe, for example, for safety reasons, you want to do at least, I don't know, like 1,000 count per minute, something of that sort, right? What is the problem with this count? Why is it different than the x and y? The problem is you want to be independent of each time you count because it has to capture these, right? X and y are calculated each time from the beginning for the current time. Like we do x and y now, 5 minutes we do another x and y. So these are kind of independent things. But count has to be here and then reflect here. Because if you count every time differently, then you count 0, 0, 0, 0, 0. You don't carry the count forward. You want your count to carry forward with different objects or instantiations, right? So as you can tell, this now will need the static reserved word because you want count to exist and reserve its value across different objects, right? Then our count would be static, right? And then also we have to initialize count for sure by 0 to make sure that we calibrate at the beginning. Good. And then that means we initialize our count at the constructor, and then each time we create an object or calculate x and y, we increase our counter by 1. Good? So let's see how we do this. This is our class, which we call point. And then x and y are just normal variables, and they are private, which is our programming approach right now. You just access them using get and set. But also you define your static variable as count and you initialize it to 0. Good. And then what is this? What is this pointing? What is this method? Maybe from this side, for the guys who are looking and laughing, maybe they can provide us some input of what is this point method? Yeah, it's the constructor, right? And then what it does, it takes 2 inputs and then assign them using the set. Here we use the set function or the method to assign them to the x and y. Good. But also it does another thing, which is increasing the count by 1. What will happen here is we know that constructors are getting called by default, right? If every time you create a new object, which means your count is going to be created to be incremented by default each time you define a new object, right? Okay. And then our set is just simply saying taking 2 inputs, x v and y v, and then say x equal x v and y x equal y v, right? Good. One thing that is important is, do we have to use this here or no? What do you think? Yeah. No, why? Yeah, we didn't have, yeah, sure, that's correct, thank you. We didn't have other variables here that are called x and y, which means if you just refer to x and y by their name, there is only one version of them. But if you add other variables that are also called the same name x and y and you want to access these ones, then you have to use this, right? Good. And then the get is just returning the value of x and y. Great. Something that is mentioned here is if you didn't initialize your static variable, and again, this is the same thing for C, static variables are get initialized by default to 0. If you didn't initialize them, that's okay. They are going to be initialized to 0 anyway. This explaining what we have said is if the constructor executes the set and then increments the count every time you define a new object, then initialize the field x of this object. The same thing that we have just said. So now we have one problem, right? We incremented count. But how can we use it? We don't have access to it. Why we don't have access to it? Yeah? Some new names, some kind of new faces. Yeah? Why you don't have access to the count variable here? It's like a very basic question. Yeah. It's a private, right? I incremented it. I have the value, but I don't have access. How can I utilize this? It's just within the class. If you remember the black box thing, I don't have access to the count from outside the thing. So if I want to use point in my main or in another class, what do I do with count? Nothing. I don't even know that this count is being created or added. Or this is a feature that is not visible to the user, right? So I need something to get across this. What can I do? What do you think? Yeah. Similar to what we have done yesterday and here for the, right? It's like define another function that has access to the count variable, right? Good. So we have to define a public method, maybe we call it getCount, that returns the value of count if I want to check whether the count has been going through or not. Good. Should getCount be an instance method? First of all, what is an instance method? It's similar to an instance variable. It means it's not static, right? By default, functions that are accessing. First of all, let me see what you think. Now getCount is a method that is interacting with a static variable, which is count, right? Do I have to make it static or just keep it as normal instance variable? What do you think? An instance method? Don't look, you have the slides, so don't look into the slides, right? Just think, right? Think, what should you do? You want to get the value of count, right? But the thing is, if you define, think of the two situations. You either define it as static or just an instance method. An instance method you just create it when you create a new object, right? Count exists all the time. Now, if you define it as an instance method, it exists only if you define an object. And it's associated with a certain object. And it's going to have different, like basically the method itself will replicate itself across the objects, right? So the method of, like let's say I define new objects, point 1 and point 2. If it's an instance method, so the method in point 1 is different than the method in point 2. It's a different version, right? But I should do exactly the same thing across objects because I'm interacting with a static one memory location variable, right? Which is our count. So it should be static, right? Because you want to interact with something, that means you should be able to get its value across its persistence, right? Across like its existence in the memory. If I define this as an instance method, I will not be able to get the count, for example, unless I define an object, right? So think of this. You define your method as just an instance method, normal, not static method. You created your class, that means count is placed in the memory, instantiated to 0. What if I want to get the value of count now? You cannot. You have to define a new object and then use its method to get the count, right? On the other hand, if you define the method as static, you don't need to define an object. It's exactly the same rules that apply to instance variables, instance methods. The method will exist in the memory no matter whether you define an object or not. And then you can access your count variable across all the time. Good? So just take it as a normal rule. Methods that are dealing with static variables, make them static. Good? Okay, so let's see how this method looks. So yeah, static method, you can use it the same as the like the static variable. You refer to it using the class name dot the method name. If you also use the object name dot method name, it's okay. It's going to refer to the same method anyway, right? And then what it's saying here is you just use you can use the method name inside the class if you don't need to use the class name inside the class itself, right? It's like saying you need to use this dot, but inside the class. This is optional because you have only one method with this name. Good? Okay. These are exactly all the rules that apply to like static variables, the same thing. You can use it for objects or classes, but it's not dependent on a certain object. Everything is referring to the same name. So let's see now the static method, which we call here getCount. You just define it as now public to enable the user to use it to access the static variable count here, and then you return the count, right? It's like a getter method, but a static getter method for a static variable, right? Good. So let's now see if we define already this class. Let's see how we use it, right? Let's see how to use it to record different x and y points for the flight, and then see what is the count. Right? So here in this example, at the first line, I didn't instantiate any object of this class, right? Which means you have no place in memory except for the static variable and static function. So if you use point.getCount, here we are using the class name itself, which is okay for a static function or static method. If you use point.getCount, what you should expect to get? Yeah? 0, right? Because you initialize it to 0 by default. And then, as a next step, I define a new object that is called B1, new point 48. 48 is going to assign x as 4, y as 8 from the constructor. And then by just instantiating a new object, what will happen in the constructor? I said you initialize x and y to 4 and 8, but we did a third thing. What was the third thing we did in the constructor? If I find you that not interactive, I'm kind of telling myself you guys should have a quiz right now. What do we do in the constructor? What is even the main purpose of this example? We initialize the x and y, but then we did a third thing, right? Which is, increasing the count. Because each time you define a new object, you need to say, I already counted the coordinates right now, right? So by just doing this, the count in the background is going to be incremented by 1. Thus, if you print line point to get count here, is going to be 1, right? Because you counted 1. And then here is just showing you that you can here refer to the get count by point, which is the class name, or B1, which is the object name. What you should expect as an output from both will be 1, right? It's just telling you that you can use this or this, it doesn't matter. Both are referring to the same place in memory, right? And then we define a new object of the same class we call B2. Then we initialize x and y to 7 and 0. Now if I print count, what you should expect? What is the value of count? Yeah? Yeah? Should be 2, right? Because you added another count. Each time you create a new object, you just increase count by 1, right? Is there any question here? I observe you guys have less questions in Java compared to C. You either gave up or you are more comfortable with programming right now, which is good, or you know Java from before. Which one of these is the case? Yeah? Yeah? It's the midterm period during the semester. So, no question? Okay. So by this, we are done 5 minutes early today, if you have no questions. I honestly said maybe I should have a quiz for the 5 minutes, but then I said no, maybe just you guys leave early and next time we do a quiz. Thanks.